Fleetly, a web application to manage your fleet of robots. It integrates flawless with ROS2 and Bigbot. So Fleetly manages a fleet of robots in real time in the browser, and it's free. It is useful for any ROS2 robot. It interfaces with nav2, which is a navigation stack well known in the ROS ecosystem. So if you use that on your robots, you don't need much tinkering. It pretty much works out of the box. The focus is on outdoor applications, since you can define jobs in Fleetly typically used in agriculture like field coverage operations. You need to make an account, which is free. Just need to email or Google or GitHub credentials. So here you can define field coverage patterns, but first let me show you how to get started. Because you will need a robot to start with, I provide a ROS package called Bigbot Cloud, which you can use. It provides an MQTT bridge between the robot and Fleetly that enables status updates, service control and path execution. But let's start with the simulation of a robot. This way you can test Fleetly without actual hardware. I've made a containerized application that runs the Bigbot ROS stack, including a gazebo simulator. It runs a full nav2 stack with a custom Bigbot controller, which ensures smooth navigation without sharp turns. Just like a physical robot, it links to Fleetly via the MQTT bridge. I use Podman to run the container because it runs rootless. I have not tried Docker for deployment, but it may very well work. You need to save your MQTT credentials in environmental variables. The MQTT network needs to be exposed to the internet. I use HiveMQ that provides a broker. Its free cloud plan integrates smoothly with Fleetly. Just create user profiles in the Cloud Console and retrieve the MQTT credentials. So you also need those MQTT credentials for the Fleetly app. Here you fill them in. I already have a simulation running and I checked that the generated MQTT messages are okay. A green light means you connected to the broker successfully. I just define my Foxglove slug so the app starts the correct Foxglove app later. Now I can define my robot. When you defined your simulation, you also defined a robot name. This robot name needs to be filled in here. Also, I have a Foxglove tunnel running. This is not running in the standard simulation, so you would need to add it yourself. I exposed the Foxglove bridge securely on the internet via a tunnel, which is protected with a Zero Trust app. So now the WebSocket is accessible everywhere, but not by everyone. I describe some ways to securely expose your Foxglove bridge in the Getting Started section. Now that the robot is defined, we can see the service status. Since the simulation is already running, it shows online. The services that you see here are a selection of services running on the robot itself. It is part of the service management framework systemd. I make a habit of wrapping ROS launch files in a service so I can better manage them. And as you can see, they can also be managed via the Fleetly web app now. You can stop and start services remotely. The GPS location is known, so the map shows the correct location of the robot. Since the gazebo simulator runs the Sonoma Raceway environment, it is located here. However, when first running Fleetly, it starts up in the Netherlands. In the map layer preference, we can just type the location and it will, most likely, recognize it and retrieve the latitude and longitude. Also, you can use the satellite image instead of the OpenStreetMap. The benefit is that you can zoom in more. Now we can define a field. A field is a surface that needs to be covered like in agriculture with rows of crops. Just click the triangle and define your area. Double click to finish. You may drag points or add points and then you must save the changes. Now we have to define the distance between the rows and the turning radius. When this configuration is saved, we can generate a field coverage path. The generated path can be shown on the screen and then be sent to the robot via MQTT. When the robot receives it, it then translates the global positions into a local map and uses a nav2 client to send the path to the nav2 server. That is executed, and the fun thing is of course that you can see the progress live in Fleetly. The update rate is 1 second and sufficient to see where you are. Here you see Foxglove received the path correctly and the robot is executing it. It has a higher bandwidth than Fleetly, so it's very useful for analysis and troubleshooting. Here the generated path again, so you see it matches, always nice to see. So what we achieved, within 5 minutes we have a robot working in Fleetly, we get all status information, are able to generate a field coverage operation and send it to the robot, which executes it successfully. I hope this video will make you curious. I invite you to try out Fleetly for yourself.